I do want to thank new members who've joined this past month. These are the new people who've joined: Kimberly Lovering, David Malden, Becky Neal, Zach Smith, Martha Wood, Kevin Allenson, Robert Circus, Garrett Burud, I think that's how you pronounce it, Crystal Haka, and Raymond Henry. And I've seen several of those names come through, so thank you for attending our meeting and thank you for joining our club. I also want to thank and recognize the board members that we have serving this year. I'm your president, and Ed Gill is our vice president. He's the one who arranges all of our programs. John Geromini is our treasurer, and he'll be making a presentation a little bit later on in the business meeting. Tila Foss is currently our secretary. And then general board members, you have Tom Roth, Cy Simonson, Jerry Gardner, and Larry Barker. So thank you to all of y'all for doing what you do to help make this club run. For those of you who are new, a little bit of history about the Fort Worth Astronomical Society. We're one of the first adult amateur astronomy clubs that formed in the country. And it was founded by a lady called Charlie Mary Noble. It was founded 71 years ago in 1949. And it grew out of a junior astronomy club when so many parents were coming to the meetings and they were interested. So they just formed their adult club. And right now we have a little bit over 100 paid members. If you recognize the name Noble, the Noble Planetarium at the museum is named after Charlie Mary Noble. We do invite your participation, especially to those new club members. We have club members in our area that have a wide range of experience, from those of us who are beginners and those who are professional astronomers. And one of the things I've always considered a strength of our club is the varied number of interests of our different members. People who do binocular viewing, people who view the constellations, and then the astrophotographers who give us all sorts of wonderful pictures to look at. So whatever you're interested in, there are people you can work with and get help from. We do have a lot of members who are willing to help answer any of those questions you might have. So especially for you new members, sign up for the group's iOS site so that you can get on the group email, and any questions you have, you can ask and somebody will probably answer. Right now, due to the current situation, just like we're not meeting in person, we're still not having in-person star parties. I know Chris has been working to have some virtual star parties, and he'll gladly help you if you want to learn how to host one yourself. And I think he's also asked for help if somebody wants to help co-host one with him. He may be trying to put one together for this weekend, depending on the weather. So you can reach out to him, and I'm sure he will let us know also. Do remember that our club, the Fort Worth Astronomical Society, is a nonprofit organization. So if you would like to make a donation, feel free. You can claim that on your yearly tax filing. Those of you who are new, again, we have 2 dark sky sites. Please, if you are a new member, do not go to either of these sites without going with another member. Again, on the group site, somebody will normally post, hey, I'm going out to Star Ranch tonight. I'm going out to Thompson's on Saturday. And feel free to reach out and say, hey, I'm a new member. Can I go with you, or can I meet you somewhere? This is especially important for Thompson Foundation because that is a land that we are invited guests to, and we want to make sure that everybody knows the use rules in that area. Thompson Foundation is located in Decatur. At Thompson, you do have electricity available, and there is a restroom available. We also have a dark sky site, Star Ranch, that is in Ranger, Texas. Electricity is provided via solar panels, and there is a composting toilet available, but there is no water. So please be careful if you're a smoker, don't light any fires, anything like that. Those of you who've been on the group, we do have a new lock on the gate, and it does have a new code. So before you go out to Star Ranch, you will want to go to the group's IO and check the files to get the new code for that lock. That's the one coming off of the road onto that easement. The locks that are directly on the Star Ranch gate those have not changed. Those are still the same. Okay, I think now, Ed, if you would like to introduce our speaker for the evening, we'll go ahead and let you hopefully unmute. Hold on a second. Who's Edward? This is Edward.
All right.
Okay, there you go.
Can you hear me?
Yes, can hear you.
Okay. I wanted to make sure because I've been setting up my microphone and camera, and so it doesn't show my dirty office. All right. Tonight we have a presentation on the Swenson Observatory for Astronomical Research, SOFAR, SOFAR. And we have two presenters. We have Dr. Richard Olenick and Mr. Arthur Sweeney. Dr. Olenick is a professor of physics at the University of Dallas, and he teaches astronomy and astrophysics as well as advanced physics courses. His interest lies in exoplanet research and binary star evolution. And my cat just stood up in front of my crib notes, so I will get her out of the way. We can tell this is a very much amateur operation here. And Dr. Olenick received a Fulbright scholarship, I believe, to the Moscow University and helped produce a series for public broadcasting. And it was called The Mechanical Universe, and he wrote the college textbook for it. Mr. Arthur Sweeney is an adjunct professor or instructor, at the physics department at the University of Dallas. And Mr. Sweeney is a retired instrument engineer scientist. He has interest in instrument development and exoplanet searches. And he's also the founder of A.F. Sweeney and Associates, a real-time computer systems consulting company. So at this point, I'm going to turn it over, and I see Mr. Sweeney is up on the screen, so I will turn it over to Mr. Sweeney to, and I hope I'm pronouncing your name right, to start off the presentation.
Hi, absolutely. Thank you. It's a pleasure being here. Thank you for inviting us, Ed. And it's nice to see all you guys and meet you. And we're going to be presenting on the astronomical research we've been doing for the last 4 or 5 years at the University of Dallas. And that will tie in eventually to a new remote observatory that's just been built in this area. So I'm going to start by turning it over to Dr. Olenick. He has the presentation slides, and he'll take it from there.
You need to enable me to screen share, please. Hello? You're muted also. Okay.
Okay. Now, can you share you should be able to share your own screen.
Nope, it says host disabled participant screen sharing.
Share. Okay, we're going to have to ask somebody who knows Zoom to tell me how to do that, because I thought you could share your own screen.
Yeah, but you had it when you invited everybody, I think, to have, like, you had us all muted.
Yes.
You should have, look under my name and see if you can go and say allow screen share.
I don't see that option. Do you not have a button at the bottom that says share screen?
Yes, that's when I click it, it says host disabled participant screen sharing.
Okay. See if you can share now. I've changed it to multiple participants. Can you do that?
Okay.
Okay.
Yes.
Sorry about that. Learned
No
something new, I guess.
So next I have to ask, do you see my screen now?
Yes.
Okay.
From ground to space telescopes.
Right, I'm not seeing it though, so hold on one second. All righty.
He's waving at you.
I don't know why I'm, okay, I think this will work though. Okay, I'd like to thank you for inviting us. And I was going to talk somewhat about space telescopes too, but I figured everyone's more interested in ground telescopes. So we're going to focus a little bit more on that. And if anybody has questions, I can tell you about our work with Kepler satellite, which was actually kind of a lot of fun too, that anyone can also do now because all the data has been released. So what we're going to do, it's not forwarding, let's see. Okay, are you seeing a new slide now, please?
Yes.
Okay.
Yes, we are.
Okay, so let's go here. So if we start to talk about looking for exoplanets, that's one of the things we've been looking for in our research. We realize that there are lots of discoveries made primarily by Kepler, and nowadays tests has been coming along. Also by just amateurs have made some too, and just regular university professors have made some. We have lots of new projects to search for them. And I'm going to tell you about how our project and how we've progressed over time to do this. So, okay. So you may know that the principal ways of gathering information about whether there's a planet around another star involve the radial velocity method, which is going to be the fact that now we can sensitively measure the Doppler shifts in light coming from the star as the planet tugs on the star and makes it move just ever so slightly. And that started happening in the 1980s, and we were able to start to measure this. And so radial velocity has become a really great way of finding planets, but it's not something that's accessible to everyone. You have to have a very large, well, not a very large, but let's say half a meter to meter diameter telescope and a good spectrometer to do that. Astrometry is another way that's been used. Gaia had hoped to find some, and I think it has actually found some planets by precision astrometric measurements. But by far the most common and the largest number of planets have been found by transit. And so transits, again, is going to occur when planets dim the light from a star by passing in front of it. So perhaps some of you observed the transit of Venus in 2012. Can anybody want to raise your hand if you saw it? Yeah, that was kind of fun. This is a picture I took through an 8-inch telescope at that time. It was pretty exciting for me, and I just had a little point and shoot camera there that I used for it. But you see the basic idea. So here Venus is going past the sun. We're going to do similar things for planets going around other stars. Of course, the problem is these stars are hundreds of light years away to maybe 1,000 or so. and it's going to be a very small dim. One of the numbers I've heard as a comparison is it would be like detecting the change in brightness of a headlight of a car a mile away when a mosquito flies across it. So very good. But we've got the technology now to be able to do that, even at small undergraduate colleges. So here's a little slide that should be animated. I don't see why it's not animating, but it would trace out as a planet goes across the star, you would see the brightness change over time. Okay, so I'll go on to the next one. So a few things about it, which is really amazing too. If you can, using your CCD camera, measure the light curve, which is going to be the brightness of the star, the magnitude of the star over time, then there are a few quantities you can measure that will tell us a lot about about the star and about the planet. One of them is going to be how much it dips. Okay, that'd be the change in flux. And that's going to be proportional to the size of the planet relative to the size of the star. And you can see it's a dip here. Usually those are maybe around 30 to 50 millimags. So 30 to 50 thousandths of a magnitude. Plot this versus time. The other thing we can do is measure the total time of the eclipse from the ingress, which is over here, to the egress, when it's over here, and then the time that it's flat. And then the last thing is that we can measure what we hope is going to be a period of the the planet going around the star, and a little bit more about that later. So it's going to come down to 4 quantities that you can measure. You can do this with an 8-inch telescope, and I really would urge you to measure some known exoplanets. There are sites I'll gladly tell you about that provide data on when to look for a transit. We've done that at the university. I even had a student do a thesis on the planet HD 189733b, which is in the corona of the star, and it's losing mass as it's orbiting the star. And we were able to also look at some historical data and predict that in 90 million years, the planet will crash into the star. So 4 things that you would measure. The actual shape of a transit usually is curved because of the limb darkening. As you're looking through more atmosphere of the star on the sides, it appears darker. So you usually get a curved shape for the transit. And we'll look at some of those. So suppose you want to go out and you want to find planets. What are you going to do? Well, it's a lot like playing the lottery. You know, you never can win the lottery if you don't buy a ticket. And the more often you play, the better that chance you might have. And if you buy lots of tickets, that's even better. I'm not endorsing that you do this, by the way, but this is going to be a similar thing. So if you can look at lots of stars and observe them as often as you can, then you have a better chance of finding new transits. And that's what we were trying to do in our research. So one of the things is, you may know the Kepler satellite operated for 10 years and then kind of ran out of one fuel in one axis. And then an engineer came up with a brilliant idea to use sunlight, pressure from sunlight, to keep it as it drifts along the ecliptic. And that was the Kepler-2 mission. So when we first started this, there was the Kepler mission, and you can see the constellation Cygnus and the area of the sky that it was fixed on between Cygnus and Lyra. So we made sure when we started looking at stars that we weren't anywhere in there. We wanted to find something new. So we're usually looking around Hercules and maybe up here towards Lyra, but we're really are trying to avoid those regions. So let's see how you would find stars, planets around stars. So the first thing you want to do is get your data from your camera, and we'll be talking about taking the raw data, the camera images, and putting them into a pipeline. Arthur will talk about that in a second. But the first thing is you would record the magnitude of the star versus time. And here is some data, and you can actually see these nice dips. They're very clear here. Okay, this was not taken by us. This is actually Kepler data. So it's very, very good data. And there's other things going on in the star, but these dips are what become pretty interesting there. So that's the first thing. And then what you can do is determine the period between each transit, which gives you the orbital period of the planet around the star. Okay. Next thing is you can remove those bumps and wiggles that we saw earlier. Some are going to be from atmospheric effects if you're using a ground-based telescope. And we can remove them and just pull out all of these transits. As you can see, here we're observing for about 140 days. There's lots of transits. The longer you observe, the better chance you have of catching these. And also it builds up statistics, which really helps you in your analysis. Okay, the next step is when you find a period, and again, I'll talk about how you get the period in a second, you can create a phase-folded diagram for it. So basically what we're doing is we're taking one of the transits, and then when we go to start the next one, we don't keep going in time, we jump back to the beginning here, and we plot the data over again, because it's the same period, and we keep plotting the data over and over, and that will be the phase, which is basically the time divided by the period. So we're able to create many superimposed transits, which again improves our statistics and our data and things we can find. Okay, next step will be to find basically the best fit that you can here and depth. There are several programs that we have used that you can use. One of the ones, I don't know if anybody's ever heard of AstroImage-J. Has anyone ever used that? It's a very good free program, runs on PCs with no problem, and that will actually take your images, your CCD images, and if you have the candidate star in place and have a comparison and a check star, it will actually produce the light curve for you, and it will also start to work with, if you know the period, you can also get the phase folded diagram to work with. So that's a little bit of software that's useful. Okay, so I'm going to transition to how we got our data, what kind of data we got, what we found. And we go back to when we really started this, which is about 10 years ago. We would go to Pitkin, Colorado, which is in the middle of nowhere. Here's the town down here in the winter. We weren't going there in the winter, but I would take students, they're doing their research for their thesis, and they would spend 2 months there taking data. And this, Arthur will be describing some of the scenes there. It's a good opportunity. Got pretty cold at night, especially in May. It'd be below freezing. Once I had a student go out to check the telescope and he was followed by a bear. So that was a little bit of a surprise, but you know, these kids do pretty well there. So Arthur, I'll give it to you now.
Okay, well, this is, I believe, the first setup that we set up many years ago. It was pretty primitive, as you could tell. It consisted of a, basically, what we call Fat Boy, that telescope there. It looks like a telescope. It's actually a 230 millimeter television lens that we picked up, and we outfitted it with an ST10 camera. We had to machine an interface for it. And we put on a little guide scope there because we really didn't know what to expect. And I believe it's on a Celestron CGE Pro mount. And next to it would be a table with a computer on it. Next slide. We would, the students would go out there and basically every single night from an hour and a half after sundown till sunup, they would take images. I believe we took 2-minute images, and every single night we would take an image of the exact same field. We would center the system on a star that was usually 8th or 9th magnitude. So it was easy to find. We'd center it there and take the same field. It was about, I think, 3-degree field of view. And the students would do that every night, all night long. Next slide. Another year later, this is probably a few years later, we were able to upgrade to a software BISC ME2 mount. And this astrograph right here is a 6-inch f4.8 astrograph. And this is the Fat Boy astrograph. This is basically the television telephoto lens that we use to take data with. So this was several years later. Next slide. And this is the Fat Boy astrograph at the North Texas Observatory, which they call MONROE. And at MONROE, there are several 16-inch RC instruments we use for follow-up. You're going to see that when you get data with what is essentially a telephoto lens, we get a really wide field of view, and we get maybe 2,000 stars in the field of view. As Richard said, you want to look at as many stars as possible, and you want to look as many times as possible, because it's basically, you're playing a game of statistics. But when you use a wide angled lens and a wide field telescope, you don't get a really good signal to noise ratio, especially if you're taking images at 2 minutes. So as you're going to see a little later on, when you fold these potential light curves, they're very, very noisy, and sometimes you can just barely tell if anything's there. So what we do is we look at that and we try to calculate the elements of the transit, and then follow up with a 16-inch telescope on that specific star to see if that transit reappears. If it does, then we can pretty much be assured that what we think is a transit may be a transit. Next slide. This was, I think, the first year. This is just a picture of some of the software we used. At this time, we were using CCD Soft. I think we stopped using that the next year. We were using that for, I don't remember, I think it was an ST10 camera. And we used PhD guiding for guiding. It ran the guide scope. And this is the CCD Soft CCD image. This is the PhD guiding, and this is the error in guiding that we saw. And the students would have to check this every 5 or 10 minutes at night, because clouds would come over and it would stop guiding, and they'd have to reacquire the target star and keep the thing running. So we were very fortunate to have some students who wanted to graduate and were willing to do a little bit of work. It's really handy. Next slide. And this is what one of the students would look like sitting out there in the middle of the night taking data. And you can see our very clever counterweights here. And So this is how it would be set up for them with a portable computer, and they would sit next to the mount. And then later on, we ran cables from the telescope system into their cabin, which was right next to the mounts, and they would be able to do this from inside where it was warm and dry. In the mountains, we have a lot of trouble with frost, so we had to have heaters on our telescopes. You can see them here, and we had a lot of dew problems. And then we eventually had to build shields for the laptops when they were outside, because the laptops would freeze up. Next slide. Okay, we're going to be talking about the data processing pipeline. This is an image, a typical image we took. It's a 2-minute image, and it was taken with the Fat Boy Astrograph, which is the 230 millimeter television lens. And this will give you an idea of what the image looked like. And you can see small stars here. There are actually a lot more stars in this image than you can see in this slide. Next slide, please. We have software, it's called Sextractor, which is free. And it would take an image and essentially, make a long story short, it would process the image and it would isolate each star in the image according to the parameters you set. And then it would measure the magnitude or the differential magnitude of that star. Now, I want you to notice right here, you see there's a bright star here, and then there's a little arc of 3, 4, 5 small stars. Richard, would you go back one slide? Okay, what you just saw from Sextractor was this star here with this little bitty arc of 5 stars. Okay, go forward. So you can see that this Sextractor program is very good at pulling these images out. When we did this in the old days, we get about 2,000 stars per image. Nowadays, we get upwards of 5,000 to 6,000 stars per image. We're using different equipment, and it's a little bit better. We have wider fields. Okay, next star. This is basically the routine we would use. We would start up, and this was a routine for the MONROE Observatory, which is a remote observatory. We'd start out by turning the power on the computers, opening the roof. We then would bring up the SkyX Pro software, which would control our mount, and it was a bisque mount. We used Maxim DL for our camera control, and we used Maxim DL for guiding. And then in the last few years, we have gone to a program called CCD Autopilot. And CCD Autopilot is really, really nice because it will essentially integrate the telescope control software, the guiding software, and the CCD imaging software into one package. So we could essentially set up CCD Autopilot and say, we want to go to this star and we want to take 2-minute images from this time to this time, and we want you to guide on it, and we just click one button and it does it. And it does it flawlessly unless clouds come up. And if you're lucky, it will recover from those clouds and maybe reacquire the object. If you're not lucky, it won't. So that's the way that's kind of the process of operating the remote observatory, or doing it in person if you happen to be sitting out on a mountaintop in the middle of the night. This is the processing pipeline for the actual data processing. We would take all of the image, and then we typically have 200 images per night. And we would calibrate those using a program called AIP for Windows. And we would have dark frames, bias frames, and flat fields. If y'all have any questions about any of this, this stuff we're talking about, feel free to speak up. You can speak up now or at the end, where there'll be a question and answer period. Basically, flat fields correct for vignetting in the lens system, and bias frames correct for electronic noise, and dark frames collect for thermal noise. Then we would take those calibrated 200 images and feed them into astronomy, do the astrometry program, star extractor. And we wrote a program, or I wrote a program that essentially uses Visual Basic and Windows scripting to tie all this together. It would make lists of images and feed them from one program to the next program. And so it's all kind of automatic now. We just simply line up all the files and push some buttons. Then we would run a program which we wrote, which would remove systematic errors like clouds coming over. We had an attempt to remove those errors that would be caused by the system, and they were about 20% effective. And then we would come up with a final light curve of each star. So at the end of each night, we would have light curves for 200 stars. I'm sorry, light curves for 2,000 stars, and each light curve would have about 200 points in it. Then the program that we wrote would then convert that and put it in an SQL database. And we have all of this data for 6 or 8 years in the SQL database, and some of it is online. Then we would analyze the data, and this was particularly Richard's forte, using several programs, and Peranzo is a very key one. Peranzo program takes the light curves and looks for transits. It looks for periodic phenomena. And I'll say at this point, we have, since we started, we have, I believe, 7 potential planets that we found with this particular procedure. But at the same time, we discovered between 13 and 15 new variable stars, which really stand out. There's no doubt about it. And we published papers. So really, when you're looking for these little bitty planets, you stumble across a whole lot of new variable stars, which is a very, very rewarding program. And then Richard will tell you, I think, about another planet we've discovered, not through this method, but from another method. Next slide. Richard? You're muted. Can somebody unmute Richard? Michelle?
I think Michelle.
Okay, now I'm okay. Now I think we got it.
You got it?
Yep. All right. So what we were looking at before was this Peranzo plots your data. So here's the data of a transit candidate. And over here, we have a phase folded curve. You might see the slight dip.
We're not seeing it, Richard.
Okay, hold on.
There we go.
Okay. And so here is the data, the light curve data, the magnitude versus time. And then this would be a phase folded when we use Peranzo to determine a period of some of the dips that are hidden inside of here. It's one dip towards the end over here. So the next thing I want to mention is that we had those 4 things that we could measure: the period, which is the time for the planet to go around the star, the time in which it was flat at the bottom, and the transit, the total time of the transit, and that decrease in flux. And then there are these equations, which is quite remarkable how those 4 parameters here will lead us to figuring out things like the orbital radius of the star, the inclination, the orbital radius of the planet, the inclination of the orbit, the size of the star compared to the sun, the size of the planet compared to the sun. So we're able to actually deduce these things from measuring that. So what we would do is once we had a candidate, I had a student write a program to put all this into Python and to compute these quantities, and then we could see if they're making sense. So here is some data where we've got it. You can see it's not a very good dip. As Arthur mentioned, there's lots of noise in here. The other thing is that there's some spread in the data from that noise, but you can see how dense the data is because, again, this is our phase curve, and we've taken all that 35 nights of data and put it on top of each other. I believe that this particular one had something like 16 transits that were caught in our data. So then I used a program to fit this curve here to it, transit curve, and that program also tells us those 4 parameters that we would like to know, and we can determine things about the star and planet. Now here are a few other ones. These are all, again, remember, suspected transits. That one was probably a good one. This one's probably not a good one on the second to the right, in the middle. Probably a good one here and a good one here. So we tried, and this is where I stayed up all night for months going through each star in those 5,000 stars that we'd have from a summer run, trying to say, okay, is there anything here? Is there anything there's this looking at? So these were some of the candidates. But again, as Arthur mentioned, it's not really a transiting planet until it can be confirmed by either other astronomers making transit observations or by radial velocity measurements. So that would be it. So it could be reported, but it's not going to be confirmed right then. So the transit method is something that all sorts of levels of astronomers can actually do with an 8-inch and larger telescopes. And again, I would suggest trying to observe some known exoplanets. And it's quite exciting when you get data on the first one and you see it appear with that actual dip that's there. And then, you can report the discovery, and I think other people will come along and take radial velocity measurements or other measurements with it. So now I'm going to turn it over to Arthur again for a bit.
Okay, well, I just wanted to cover the fact that after a few years, we discovered that it might be a little easier to do this remotely from our bedroom or living room. So we have basically moved all of our research to remote observatories. And you folks are probably all familiar with the remote observatories. They're becoming the only way to do research these days. I understand the joy of going out and looking at the stars, and that's certainly something that I love to do, and I'm sure you all do too, or you wouldn't be a member of the club. But when we want to take data or do astrophotography, sometimes we get a lot more accomplished if we can do it remotely. So we started out using this observatory here, which is the MONROE Observatory. It's named for the man who donated the land. It belongs to the University of North Texas. And you can see there, Fat Boy, in the MONROE Observatory. That was, I believe, the first year we did remote. Okay, next slide, Richard.
So I think I'm going to talk about some of those other discoveries. Probably were a little out of sync there in that I think I had one slide out of order. But besides exoplanets, we find there's other things in data, and this makes it even doubly exciting. And some of those are going to be WRC Majoris binary stars, and are early arrays that are exhibiting interesting effects like the Blaschko effect. So here is 1W Ursa Majoris star that we found in our data, and very, very beautiful signal, as you can see. These type of stars are characterized by the fact that it looks kind of like a W. Look at this, and there's really two dips because it's a binary, and the stars are very close to each other. They probably have a common envelope even, and they are orbiting each other, of course, and they are doing this in a fairly rapid period. This one here is 0.36 days. So you're looking at, maybe, I would say 8 hours roughly for the stars to orbit each other. So we found these, and here is a diagram of the periodogram from Paranzo. It's picking up.
Richard, we can't see your cursor, so you might just
explain
which one you're looking at.
Okay, so the upper one is our light curve here that looks like a W, and the lower graph down here is from Paranzo, which is the periodogram. So it's plotting the power in a signal in a particular frequency versus the frequency. And there's the spike here. These other ones are due to one-day observations between each of our days. We had a period of 1 day appearing, so these are aliases that appear there. So the next step, this was a student's thesis, was to go in, and we used software Phoebe out of Villanova University, Ed Guinan, and I don't know the other, Dr. Prija made this. And you can see the red curve in the upper image here. That's our fitted model curve to it. And once you fit the model there, you're able to determine the masses of the primary and secondary, the sizes of them, the luminosities of them as well, their temperatures, and a few other parameters there. And we're able to then categorize this as an A-type W Ursa Majoris binary. The other type that's kind of exciting was RR Lyrae. So for a little refresher, you might remember the HR diagram. We're plotting temperature or spectral type down here versus absolute magnitude on this scale. And RR Lyrae are going to be in the zone here where stars are starting to evolve into red giants. There actually are red giants over here. And this instability strip has lots of types of variable stars in there. And RR Lyrae are, you might also recall, are interesting because they all have, as you can see here, absolute magnitude near zero. They're all really about the same absolute magnitude. And we can measure their apparent magnitude by just observing them, and therefore we can figure out the distance to them. So they're in a sense cosmic yardsticks, as are much more used probably are the Cepheid variables. Anyway, here is a light curve that we found in one summer's data.
This curve here represents, each one of those vertical lines is 1 night's worth of data.
Yeah. Thank you. Thank you. And we're plotting the Julian date down here. Okay. And so we run a periodogram. So we found a period here of 0.09 days. So it's about 2.4 hours or so. And when we take a phase folded diagram, you can now see how the star will rather quickly ramp up in brightness, temperature, and then slowly decrease and go back and repeat that. So this will be kind of characteristic of these stars. I like to think of them as breathing in and out as they're doing this. As they expand, they get a little cooler. They contract, they can be hotter, or they also have more energy coming to the surface right then. Here is another one this one becomes a little bit more interesting because we have several periods that look here. Here's one, and then here's another. These are in the top image. There's the highest one is going to be the actual period of the oscillations. And then we have a secondary one here. And on the left, that second peak. And then you can see two similar ones on the side. Those are going to be aliases from it. And so when we look at the phase diagram, this is really cool. You see it got brighter, but not as bright the second time. And the third time went back up to brighter again. And then next time, not as bright. So there's actually something else going on. It's not only that brightening and dimming of an earlier rate, but there's something else. So
would you go back 2 slides for a second? One more there. Notice that the magnitude of this star, it runs from 12.6 to 13. This is typical of thousands of variable stars out there. It's fairly bright. If you have a CCD camera, you can capture this easily. And note that the period is about 2 hours. So you can go out on a night and with a good telescope and CCD camera, as we said, this was a 230 millimeter lens. Within a few hours, you can actually record these changes in these variable stars.
Okay, just a little more on this. Here is another one of these. And here I had the student plot each day in a different color until you run out of colors. And then it started repeating in colors here. But I think you can just look at it and you would see it's a beat pattern. It went up, came down, goes up again. And if you squint, you can kind of see how there's like a beats, if you're familiar with beats going on there. So that was another effect. And here it is. And we took in the upper graph periodogram. This is a slightly different way of doing one, figuring out a period. And then we looked at the phase diagram for that. This one, I removed the slides where we had more detail on this, but this one actually showed the beat frequency going on here and the fact that it is the overall brightness of it is changing, getting smaller, but it's also doing it on a longer scale too, which is related to something called the Blaschko effect. And it's related to chaos and all sorts of other interesting things. So Arthur.
Okay, back to talking about remote observatories. We started out using this DSOC observatory, and I think you're probably all familiar with this because the owner of it, Preston Starr, I believe, is a member of your club. That's the DSOC observatory. The one on the right there with all the telescopes in it was the very first one built, and then he built this second one to the left. The top large scope is a 16-inch scope that we shared with the University of North Texas. Some of the equipment's ours and some of it is theirs, and that's a scope we use for looking at known exoplanets and following up on possible exoplanets. And below that is a dual astrograph that we built for an experimental run, and it's basically two 6-inch f4.8 astrographs. And we ran that for one summer and discovered that if they're not, if you point them at the same place and then flip for a meridian flip after the stars transit the meridian, you don't get to get continuous data for both stars very well. So it has some drawbacks, and I think a better solution is to go to two separate mounts and to try to put two of them on one mount. Next slide. It brings us to the SOFAR Observatory. The DSOC is 800 miles away, round trip, I believe. And it's a long way off if you have to go out there and clean the gnats off of your lens or something. So we pursued building a new remote observatory much closer to Dallas, Fort Worth, Arlington. And it's called the Swenson Observatory for Astronomical Research. It's 10 miles northwest of Throckmorton, Texas. This is a picture of the sky at the SOFAR Observatory. The land is donated by the Swenson family, and they formed a nonprofit foundation, which is called the Swenson Observatory for Astronomical Research. Next slide. And it is about 3 hours from Arlington. You can see the big white blob there labeled DFW. And then over to the left, you can see the blob labeled Abilene. Lost it. There you go. And if you go a little bit north and east of Abilene, you'll see a cross and the word SOFAR, and that's where the observatory is. And the darkness there is, it's about the same as it is as DSOC, but of course DSOC has a lot more potential because it's at about 6,000 or 8,000 feet, and SOFAR is only at 1,500 feet. But the location is extremely dry and very, very dark. Next slide. On the left there is a roll-off roof observatory. From the outside, you can see that. And on the inside, on the right, you can see the control room, or what we call the warm room. It's a joint venture with the University of Dallas, North Texas, and the Swenson Foundation. It's completely automated. We connect to it via satellite internet, and it's 20 megabits per second, and so far it's proven to be very reliable and a very good link. I really haven't had any troubles with it at all. Next slide. This is a picture of the inside of the observatory. We have provisions for 6 permanently mounted piers, and I suppose if you wanted to put things in between piers, tripods or something, you could. And basically, we built this so that we would be able to do our research in an observatory that's much closer to the DFW area, because we like to experiment, we like to change things, and it's really handy to have it nearby. Plus, you'd be amazed at the things that can go wrong in a remote observatory, and you have to actually go out there and touch something. But our mission is education and astrophotography outreach. So we're interested in amateurs and K through 12 and university educators to join us and participate in the use of this observatory. Okay, next slide. This is the second image we took from the observatory. The observatory is only totally completed about a month ago. This was the first image I took with the television telephoto lens. You'll probably recognize that as the part of the Veil Nebula. Next slide. And this is M31. It turns out that for a 230 millimeter lens and an ST10, M31 is the perfect size object. It's a really nice object to capture. Next slide. This was the comet. Here again, we were just kind of experimenting. I actually followed the stars and not the comet, and then used Deep Sky Star Tracker or Deep Sky Stacker to stack the images. Next slide. So basically, I just wanted to say to everybody, if you know anybody or any schools or educational institutes or amateur astronomers interested in astronomy research or astrophotography, we're looking for people to collaborate with and people to associate with to get this observatory so that it's used, to its fullest extent. I think it's a really good addition to the astronomy in this area of North Texas. Okay, Richard, I think that's pretty much it.
I'd like to add one thing, that maybe you would want to have some nighttime observing for your society with DSOC, and they could do it through Zoom. And I did this when we had to move our courses to online in the spring. I had 62 students in astronomy, and we were able to do a Zoom meeting with students all over the country. Arthur at the helm of the 16-inch telescope, and they were able to then see images of galaxies and nebulae appear in front of them, and they were quite excited. I mean, it really worked out well, and there was absolutely no problems with the technology. But some members might want to see how you actually work with a remote observatory, and that might be something you might consider in the future. So thank you very much.
We're also looking for replacements for our students to do surveys. As I explained, we had students man the telescope every night for a period of 2 months. At this point in time, students to do that are becoming more and more rare. So if you know of any amateurs that would like to man a telescope for 2 months to look for new objects, let us know. It's a lot easier these days with the autopilot. You just open the roof, and once you've got it set up, you push the button and go to sleep.
All right, thank you, gentlemen. Can everybody hear me? Okay. Thank you, gentlemen. We appreciate it. I think Preston is on. Do you want to say a few words, Preston?
Well, I'd like to say I enjoyed the presentation, and we worked with the University of Dallas for the last 3 or 4 years at the Dark Sky Observatory, and along with the University of North Texas at the MONROE. And so definitely being able to do science remotely and being able to do observations remotely is certainly something we believed in at the universities. Became operational in 2005. Dark Sky Observatory there across from McDonald went operational in 2012. And so we were expecting, there's a huge demand for it from amateurs to professionals to be able to be online and remote. And so I agree with everything the gentleman had to say this evening.
Okay, great, wonderful. I'm going to open up everything so that if there are any questions out there from our general club, you can go ahead and ask those. We'll see what happens. Okay, how do I unmute all? Okay, everybody has a chance to unmute if they'd like to ask a question.
I have one. If somebody else,
go ahead.
Go ahead.
How does turbulence affect your magnitude readings? You've got fluctuations in brightness, scintillation. How does that affect the noise in your magnitude readings?
Well, it produces a lot of noise, of course, but if you think about it, when you're looking at variable stars and transits, you really don't care what the absolute magnitude is. So the Sextractor program, when it goes in and gives you a magnitude for each star, it's an approximate magnitude. I found it to be, plus or minus a couple of tenths of the true magnitude. But scintillation and atmospheric turbulence and noise is probably the greatest contributor to noise in our images. So
Yeah.
that's the reason we can't just sit in one transit. We have to record 15 or 20 transits and then overlay those transits. And what that does, that tends to cancel out the noise, and we get a better signal to noise ratio by looking at many transits. But that is the main
Is
source.
it still on?
Thank you.
Yeah, this is Ed Gill.
There it goes. Okay.
First of all, I would like to thank Arthur, excuse me, and Dr. Olenick for their presentation. We're always looking for presentations, and that was a delightful one, and I thank them very much for their time and effort.
Okay. Anybody else have any other questions?
Yeah, I noticed that many of these transits seem to be inordinately short. The time periods between the transits, I mean, meaning that the orbital periods are matters of days or hours. Is that what you find as being like the universal, or do you find anything that's really longer, more like in our own solar system where nothing transits in less than 90 days?
Well, if you look at overall data, there is a range. And we actually found a star in Kepler data that has a period of something like 73 days, but it wasn't by the transit, it was by another method. But also, we're tending to find the large planets, okay, because they're going to block out more light as they go past the star, and also ones that are closer in are going to be a little bit easier to observe than the ones that are going to be farther out and away from there. So there's a prejudice in the fact that our equipment is limiting us to find those closer in stars, planets to the stars. But other, projects can find them farther out, and of course, multiple ones as well.
And we're further prejudiced to those ranges because when we look at a star for 60 days and we require, and that's with this wide angle short focal length lens, we look for 60 days and we require 15 to 20 transits in order to get the signal to noise ratio up, then that pretty much limits you to short period transits.
Any other questions?
I'm curious with those, the short transits that you described in the way that you described, that you can really only see the larger planetary bodies that are closer into the sun. Have you guys identified anything that you feel like would be within the Goldilocks zone that would potentially allow for habitable life?
Unfortunately, not so far. The planet we found around the binary, I investigated and decided it really wasn't in the Goldilocks. I thought it might have been around these two stars. I have a student working this summer on test data, and we have another planet that's basically in the corona of the star that we're trying to pull out of the data to see if it's really there. So no, we have not been successful to find one in the Goldilocks zone. That would be wonderful if we could, but we haven't. But there still are a lot of stars we have not analyzed in our data. So maybe we'll find one just right.
Dr. Olenick, a question on that. So to find a planet in a region that would have a longer period, you're talking about an observing period that would take years.
Yes. Yeah, yes, go ahead, please.
So I guess what I'm wondering about is if you've looked at a star that, say, has a couple of planets you've detected that are close by with short periods, is there any effort to set up a very long-term observing program to find other planets around that star?
There are there are actually ways where if you find one and you want to see if there are other planets that can be farther out, you can look for them, but you're not going to do it. You're going to do it somewhat by transit, but not exactly where you're going to see dips. What happens there is when a planet is farther away, it has a longer lever arm, and as a result, and usually if it's pretty massive, it can make the star wiggle too. One closer in can do it, but one farther out can do. It's going to be a little smaller effect, actually probably much smaller, but it can still cause its star to move back and forth a little as it's going around and tugging on it. And we can now observe different frequencies that we try to match up then to say, well, this could be, you know, a second planet or a third planet around that star. Sometimes we can catch actual transits, but not always. And so there's another way to see if it's there in the data, but of course you'd have to confirm it by some other means.
And for longer period transits, you know, like if you look at our solar system as typical, where you would have planets that transit, you know, in a year, 2 or 3 years, 4 or 5 years, those can only be observed by somebody looking at that star over a period of years. There are efforts underway now in the professional community and NASA and folks like that to put up some systems that will, I believe, observe the entire hemisphere every few minutes for years at a time from space. That's where they'll find those longer period transits, and they won't need 15 transits to do it. Their equipment is so good, and there's from outer space, the data will be very, very clean with almost no noise.
Yeah, an example of that would be the Kepler satellite would observe 70 in the K2 mission would observe 74 days of the exact same area in the sky. So we got really one, and we had two types of data, a long cadence, which was going to be every 3 minutes, it would download an image, or a short cadence, which was every minute. So you can imagine getting an image every minute for 74 days without breaks because there's no daytime you have to worry about. That was pretty amazing. And I've been excited because we had requested data from NASA as a guest observer, and we were looking at cataclysmic variable stars, which are binaries that are very close. One's a white dwarf, one's a red giant, and it's feeding mass to the white dwarf, and it accretes a disk around it. So we're trying to observe things about the disks. And we had one star that Kepler caught in outbursts that we requested. So we were doubly fortunate because they agreed to get the data for us. And second, it was an outburst. And it was every minute of data. Every minute we had a data point, and it's just been incredible. And we've gotten a lot of interesting information, like the disk is wobbling, and we can also tell the onset of when it goes into what's called a super outburst. So yeah, if we could have a project that would be years, that would just be phenomenal. TESS, has been up already 2 years taking measurements, but it usually does about 34 days at a time. And so it's not exactly a long stretch yet. I don't know what the future uses of it will be, but it's not quite there yet.
Thank you very much. Great presentation.
Yeah, I'd like to follow up with Arthur. After the presentation, you had mentioned with the SOFAR Observatory, you have empty spaces. I know we have a board meeting next month. The Fort Worth Astronomical Association is both looking for private site and co-op sites for setting up instruments, remote observing, public outreach, and so on. And I'd like to get some information from you on the the type of agreement, the co-op agreement that you folks have in place for organizations to put instruments in the SOFAR Observatory.
Okay, that's fine. I'll get with you tomorrow. That's okay.
All right, that's great. Thank you.
Is by any chance is the person here who handles your website?
I didn't see him here.
It's a great website.
Oh, yeah.
He's down in a basement clicking away on a keyboard to make it great.
I can get his name and talk to him myself.
Thank you. We'll get you that information. Thank you. Thank you again, gentlemen, for your presentation.
If there are no other questions, I'll leave you guys to your business meeting.
All right, very good. Thank you. Thank you very much, gentlemen. We appreciate you.
I enjoyed it.
Getting down to the business meeting, you're going to see John Geromany again. There he is. He's our treasurer, and he is going to give you the report because it's been a fun month, I think.
Yes, that's what we call it. Our current balance with our savings account and checking accounts is sitting at $60,362.85 plus another $50. So we actually had another person join yesterday after I put all these metrics together. They joined and paid and did all the wonderfulness, and I didn't see him here tonight, so I guess he wasn't able to make it. We had 10 new members join since August the 1st. We received a $100 donation from a non-member. I don't know who Timothy Battle is, other than a person who has an address in Denton. But they dropped $100 on us, so thank him for that. We got a contribution from Amazon Smile of $52.82. And for those that are not aware of it, Amazon has I wouldn't call it a charity, a contributional sharing with organizations where you get the organization gets a small percentage of whatever it is you're buying. It doesn't affect your price. It only provides for this contribution that Amazon Smile makes. And you can look up Amazon Smile. It works both in your browsers and also in mobile apps. Written out so I can attach to the meeting. Yes, the answer to that, Tila, is yes. We completed our renewal effort and ended up with, I think it was 104 paid members. So with the 10 that joined since August the 1st, we're up to 114. Those people were brought through us by going to the Facebook page that Robert Cargill has been keeping up to date. And that's where these people are. We have a total of 16 people that have started the process, but only 11 of them have completed it. So I've sent a notice to 4 of the other 5. I think the 5th person has reconsidered that, but I did send a note to the other people suggesting that they needed to pay by the end of this week, or we were going to remove their Night Sky Network registration. So that will make it about 20 days that they would have had an opportunity to reply to the request for dues. And what I don't know how many changes Sean has been making to the website, because I don't recall some of the stuff that I saw on there recently. And probably what Arthur was referencing, I think there is a, I don't know if it's showing transits of the satellites for the individual planets, but if you go back to one of the pages past the meeting, or I don't know, it's about the 4th or 5th tab on the menu. You can go back there, and those objects on that page are dynamically generated anytime you go into that page. And that's the first time I'd seen that. That doesn't, I may have slept when I was going through there the previous times. I did get a message too, by the way, from Sean that the changes were made, Michelle, that I sent through.
Okay, good.
So let me see. You went across the people that are that were added. The 11th person's name is Wagner Pedraza.
Welcome.
Actually, he lives in Dallas, off of I-30, and excuse me a minute. He, I did provide him information about the Dallas group, who happens to have a monthly, when they can have star parties, they have a monthly star party at Cedar Hill. So, which is what, 5 miles from where his apartment is, but he said, no, I want to join you guys. So I thought that
very
was
good.
pretty neat. So the Nice Guy Network roster is up to date. The group's IO roster is up to date. There are, Phil and I talked this afternoon about getting the badges sent out to people. So that's sort of an ongoing project, but it's one that I've been working on for a while just to get the data. So what we're going to end up doing is printing envelopes, and I'll send those envelopes to Phil. He'll put the badges in the envelopes with the stamps from last year's Apollo 11 celebration, and those will go to the individual people. There is a backlog of badges Phil was talking about from when people never picked up the ones that from months. so what we're going to do is get the ones that are current, the 11 new members, and get them taken care of, and then we'll start attacking the rest of it. And I think we do have the Yahoo Small Business bill coming up, I think, in a week. That pays for the domain, and I guess we're hosting the computer there as well, or using their hosted computers to run our website with. And I believe that's it.
Okay. Thank you. I think everybody needs to thank John. He has actually put in quite a bit of time and effort in getting that group's IOs cleaned up so that we don't have people who are still there who are no longer paid members. And I know that took a lot of work. So thank you very much, John, for that.
Actually, that was easier. Oh, thank you. That was easier than rewriting the new member handbook.
I can believe that. I can believe that.
So,
Michelle, can I mention something to John? This Phil.
Yes.
John, I narrowed it down to 14 badges out of the almost 200 that I have. So
really?
we're down to 14 plus the 16 that you've got.
Okay.
So
well,
we're in pretty good shape now.
We can be done by tomorrow, right?
Yeah, right. Maybe not.
Well, cool. Well, the only future activities that are left in this, the ones that I have on my radar right now, I've not actually been able to do anything else with Google Apps for nonprofits. It's just a time thing. There's a lot that goes on because we don't have a workflow that can take data out of one system, go put it in another system, and go to another system. So we have to write email messages and say, pay with PayPal, and then wait for a message to come back from Nice Time Network and so forth and so on. So we don't have any workflow concept with this. So I haven't done any work with that. We are, without a shadow of a doubt, behind on updating the hold harmless and code of conduct within Night Sky Network. So I will start taking a look at that. Unless Tila is going to be around, I'll start taking a look at that in a week or so and try to figure out some way. I certainly can programmatically compare the Google spreadsheet of the questionnaires to the content in the Night Sky Network, because what I have been doing since last year is I dump the e-group and the Night Sky Network every month. So we have a historical record of content. So those are the things I got going. Is there any questions?
Are you reading something on the chat?
No, I'm not doing that.
Oh, okay. That's okay. All right. And we can always ask questions afterwards. Hold on one second. Who is that? Oh, okay. Ed wants to talk to a couple of things. So let me unmute. I think he can unmute himself real quick.
Yeah, I'm unmuted now.
Okay.
Just a couple things. Number one, we do have a presentation set up for September. I'll be confirming this week with Steve Fisher, or excuse me, Paul Fisher. And I've been corresponding with Steve Chandler on that. But the other thing is a change in our normal procedures. Normally, November, I'll get something going for October, but November we normally have a swap meet. Yeah. And I doubt this year that we will be doing an in-person swap meet. So I'm going to run with the assumption that we will continue to do our Zoom meetings at least and through Christmas, and try to line stuff up for October and November, unless I hear objections from the congregation here, or hear objections next board meeting next month. Online swap meet, well, that ought to be interesting. I guess we could do bidding online. But yeah, so that, you know, like I said, that would be a change in our normal
yeah.
Reading comments here. That would be a change in our normal procedure. But if there's no objections, then I will work at getting something going for a November presentation for a Zoom meeting.
Okay. And we can discuss that further at the board meeting. But yeah, the governor hasn't said if or when he's going to change his rules on meetings. So, and even if we were able to hold a meeting, we'll have to find an alternate place, because I believe that the school, the university, is not opening their classrooms up at least through the end of the year. So that we'll just have to work with what we can work with.
So with that stated, I'm going to ask again for folks, if they have ideas for presentations or things that they would like to present, please contact me, and we'll get you on the calendar.
All right. Very good. Something else I want to discuss is 3RF. Right now we are scheduled for September, the weekend of September 11th through the 13th. That will be very dependent on what's going on up in the counties in the Panhandle. I spoke with Katie at 3RF this week. They will not be making a final decision until that first week in September. That will give them a couple of weeks. They've got the kids back in school. They'll see how it's going, and then they'll make a decision as to whether or not we will actually have a group at 3RF. She's already got volunteers lined up, and everything's lined up along those lines. So at the moment, we've got 29 people who are signed up for the weekend. They are actually pretty well distributed between the cabins and RVs and the bunkhouses. Right now, we've got in the women's cabin, only one person in the bunkhouse. So there won't be a problem with social distancing. It's built for 10. So even if we get another woman in there, there should be plenty of room. The men's bunkhouse, we normally lease or rent the one that houses 22 men. And right now we have in the bunkhouse at the most 7 scheduled. It may be as low as 5. So it's 5, 6, or 7 in that large house. So I think you'll be able to social distance there. And if things change between now and then, we will find out. If the September weekend does not come through, we'll look at October, and we'll just take it month, from September to October and see what's happening at that point. For those of you not familiar, the club normally pays for the bunkhouses. Again, usually one men's, one women's. We've talked about the social distancing. We're also going to adjust the way we do the Saturday evening meal. The caterer that we've spoken with is able to do boxed dinners for us. And so we won't have a buffet. We'll probably be outside instead of all crammed into a little room, so we will find a way to social distance and still visit with each other, because it is a good weekend just to even visit with other members of the club. Last year, there were quite a number of us that went, and we got rained out of all of the observing at nighttime. I think Patrick got the solar scope working for about an hour when there was a break in the clouds, but we had a great time visiting with everybody who was there and getting to know some new club members. So again, if September does not work, our backup weekend will be October 9th through the 11th, but that decision will actually not be made until that first week in September. So we will let you know. George Lutch, if you're there, do you want to say something about Prime Focus? I think I've given everybody the ability to unmute themselves.
Yeah.
Okay.
Just got a lot of good pictures last time. Anybody out there that has any equipment that they currently have or are planning on getting, if you want to share your experiences with the rest of us, I know that David recently got a rotator. So, just a paragraph, maybe 2 paragraphs. Let me know what the product is if you don't have pictures, and I will backfill with product information from the websites. But yeah, anybody that wants to just kind of throw out some information about what they're getting and what they're actually using and how they like it, feel free to throw me a line. My email is in the list, but if you need to, it's glutch@gmail.com. And look forward to whatever you want to throw at me.
Okay, great. Thank you, George. I don't know. Now let's go through the board members. Cy, I saw your face pop up there. Do you have something you want to share with us?
Remember Brandon Hamill, the guy from Minnesota that came down to us?
Yes, he was an excellent speaker.
Yeah, I went to see him while I was at the Minnesota when they had the Alcon, 3 years ago when I went and visited him. But he got in contact with me last week, and he was on some webcast or whatever. But I talked to him about 3RF. He'd always wanted to come down, so we're going to try and set him up for next year to come on down and visit us at 3RF. So I'll set that up.
Perfect.
So he's been interested in coming down for that. So other than that, I have nothing.
Okay. Does anybody else from board, Larry, Jerry, do you want to say anything? Tom,
I
you want to say
belong.
anything?
I belong to the Fort Worth Rock Club, and they're going to have a rock show the end of August, like the 29th and 30th. And evidently, they're holding it at Will Rogers complex. How are they getting away with that with the 10 people rule?
Same way as the gun shows.
Probably just like a retail store. They probably have to limit their capacity, is what I would imagine.
Okay. It's just,
Yeah, the gun shows are still going.
Yeah.
aha, money talks.
There you go.
That's what it is.
Maybe rocks are essential.
Well, yeah, they are when you're having a rock fight.
Well, I think that's everything we actually needed to discuss formally on the meeting. So again, I think I've got everybody set to unmute themselves. So if you want to unmute and talk or ask any questions of some of these other people, let's feel free to do that. Okay.
Michelle, I got one quick one, an alibi.
Yes.
You probably won't do it, but have we thought about the Christmas party just in case?
At the moment, I think we've already got the Christmas party scheduled.
Okay.
Robin had that scheduled, I want to say the 6th of December.
Okay.
So that's already scheduled at our barbecue place.
Okay, good.
The one we've been going to. Yeah.
Thanks.
Spring Creek, that's the name of it. Yeah.
If you like, I could share a little information about the upcoming September presentation that we're hoping to have with that Ed's hoping to coordinate.
Okay. Go ahead.
Oh, okay. I wasn't sure. I'm new to Zoom a little bit, so I wasn't sure if everyone could hear me or not. Ed and I are trying to coordinate a presentation we lined up for next month. The gentleman is Dr. Paul Fisher. Just a little background. Paul and I met as students at Texas A&M in the mid-1970s. He went on and did his graduate work in New Mexico, and as a grad student worked out at the VLA. In fact, he gave me a hard hat view of inside of one of those radio telescopes. Got to walk around inside of one. After his career in academia, he got an opportunity with the NRAO, the National Radio Astronomy Observatory in Charlottesville. He actually lived at the telescope in West Virginia for about a year, and now he's officed at the University of Virginia. And Paul was trying to put together a presentation for us, and hopefully he'll have that ready. Just kind of an introduction to radio astronomy. So that's what we're hoping to have for you next month.
Wonderful. Look forward to it.
Yeah, I'd say in my correspondence with Paul also, he was also talking about tying some of the radio sources into visual astronomy objects that are of interest, that as amateurs we could track down. And some of these things are very, very faint visually, but are very loud as radio sources. So yeah, I'm hoping, I haven't heard from him in a little bit, but I'm sure he'll come through, and I'm hoping we'll have a nice presentation on that.
Ed, I'll be in touch with him again also, just to make sure he's ready and has a date. And hopefully one of you all that's more adept at using Zoom than I am will be able to guide Paul into getting connected so he can share his presentation with everyone.
Yeah, thanks, Steve. Yeah, I had something else too, and I know Mark Smith has been very, very interested. I've finally made a few breakthroughs on the Palo Pinto Mountain State Park. I had a long conversation today with the Secretary of the City of Strawn, and there is a lot of interest, both from the City of Strawn and from the park, for astronomy community outreach. And in fact, as part of their master plan, they do have an astronomical viewing area planned, but it is now in their phase 2 of the Palo Pinto Mountain State Park development. Phase 1 is basically all their infrastructure. But I have a callback requested from James Adams, who's the superintendent of the park. And essentially one of the things that we can discuss is whether we would help with grant writing to pull forward their phase 2 plan and get it funded privately, because the Texas state legislature, I'm sure they've got plenty on their minds whenever, you know, every 2 years when they get together and have a beer and talk. They are all about getting private money and donations. So I think there's an opportunity there for us to see if we can do some grant writing and get involved with developing those facilities at the park, which is of course, very close to, well, it's right there at Strawn. It's very close to where we go anyway. And set that up as our public outreach. And maybe if we do get property of our own, keep it as our private area and not get involved in, you know, liability and you know, and the issues of public outreach on our own private property. So there's stuff we can discuss at the board, but I wanted to let folks know that I have made some breakthroughs with communications after multiple computer directed for this press 1, for this press 2, and I got down to press 99, which was about where I needed to be to get somebody on the line. So that's
well, thank
that's
you for persevering.
Yeah, that's the status on that.
Anybody else? Comments?
Yeah, Mike Jones here. With this SOFAR complex set up, I'm beginning to wonder if it makes less sense to get land and more sense for the club to buy a respectably large telescope and mount it out there as one of the instrument clusters. They've already solved all the logistics and tidal and power and water and all those problems. What if we started looking at buying a large telescope, like a 20-inch plane wave or similar, for the money we have instead of spending it on land? What about a large telescope at an existing facility? And so far, it looked really good to me. Just lobbing that out there for the board.
That's good information. I've got a note on that. And for those of you who are interested, there will be a board meeting in September. Those are normally held on the odd numbered months, and that will be the second Saturday of September. So we'll get information out to everybody.
Saturday? Saturday?
Oh, I'm sorry, Tuesday. It's Tuesday
Okay.
evenings. It's past my bedtime. What can I say?
Well, you know, and follow up on what Mike Jones said. That's why I followed up with Arthur Sweeney about if they have an agreement, you know, a co-op agreement for either purchase of a spot in their roll-off observatory for us to mount an instrument that we would own and operate. That's a possibility. And like you said, they've solved all the logistics, and whatever money we would be putting in the land, we could put into the instrument. And as COVID is showing us, remote observing is the way to go.
I would be glad to research a range of observatory quality instruments. Plane wave and Kerry Klebrad is coming out with a new line of similar telescopes at Optics Wave Laboratories. There's some good Cassegrain instruments coming out or available now, and if you want, I could put together a quick list ranging from, you know, economical to pretty eye-watering. And we could see, if it worked out, we would just buy a pier and a mount and a telescope and mount it at an existing facility. And rather than having to mess with all the headaches, and George Lutch knows more than anybody about searching for land. That's been a nightmare, and nothing has really panned out. So
or might be a more fiscally sustainable approach as well, long term.
Yeah.
Well, didn't we try that with Preston?
Mm-hmm. There are 3 good mounts, 10 micron, Paramount, and Astrophysics are all top shelf mounts, reliable and dependable for a remote operation. Probably going with the software BISC would maximize the software compatibility. Everybody's already got the drivers and are talking to the things. They're communicating to these drives. 10 micron is what Yuri Petrunin uses at Tech Telescopes in Colorado. He swears by them, and I've seen them run, and they are gorgeous mounts. But if it means a software incompatibility that's got to be overcome, then certainly I have a Paramount ME and love the thing. I think standardizing on the mounts, but that depends on what's out at SOFAR. I don't know what all they have out there. Did anybody see the mounts that the people are using out there? Monthy. Yeah.
I remember.
Yep.
Yeah,
By the way, software BISC does not give you a transfer of the warranty. If you buy used, that's the end of that warranty.
Okay,
Speaking from experience.
One thing to think about, if we go to some place like SOFAR, you've got 2 universities already out there. So there's always a chance that you can get foundation money to be able to host virtual star parties wherever, and we can leverage that with the money we have and could have one hell of a facility. Yep. So let's not try to define what we're going to put out there. Let's find out what we can do.
Right. And that's and Mark, that's why I asked. I wanted to open the conversation with Arthur Sweeney about what is the parameters on their co-op agreements for using space out there or purchasing space out there, and limits on the equipment and what their future plans are and that type of stuff. So yeah, I'll try to get more information back and get it to the club and discuss it at the board meeting. I think where are we going with this? I think we need to set up actually a permanent committee that manages our co-op agreements, any remote observatories, folks that have knowledge in the area, and also grant writing, because we can take our money and leverage it with grant money, depending on the use, or a co-op with one of the educational, so we share time, however we want to do it. I mean, there's multiple paths here. We just need to collect the information. But when I saw the CAC presentation, that's why I brought in this presentation, to get folks aware of what's going on out there, and that right down the road there's an observatory with only one telescope in it that has places for, looks like there's places for five or seven more scopes. Why should we burn all our money on land and insurance when we can set up equipment and have folks have remote access to it, not having to pay by the minute, and has a real benefit to the club.
This is Preston Starr, and as a club member, and been doing this a long time now, I operate the Dark Sky Observatory across from McDonald Observatory, 6,200 feet, with 22 telescopes locations already there. We can go up to a 24-inch in our existing buildings, and we can go up 1 meter at the facility. We have 1 arcsecond seeing, the same as McDonald Observatory. Once you start going up in size, the site becomes paramount. And I can tell you that I operate universities, operate commercial clients as well, and advanced individuals. So I'll be glad to give you any advice that I can as operating a business, but also as managing lease peer space for many companies and individuals and universities.
Well, Preston, I'll nominate you to be chair of that committee.
Yeah, well, I
was our resident expert.
Yeah, and I am still the observatory manager for the University of North Texas, and I operate 3 facilities. So, not saying I'm an expert, but I spent a lot of time at it. So,
well, Preston, this Mike, what are your thoughts on the club buying the entirety of the equipment and setting it up remotely at SOFAR or one of these places?
Okay, so I'm familiar with Throckmorton. It's a good place out on the high plains and 110 degrees in the summertime. Where Fort Davis is 74 degrees right now, and it settles down within a few degrees, and your seeing is 1 arcsecond. So I can tell you right now that I have the best location of any major observatory location in the southwestern United States. It's the darkest site, going to be that way for a long time, and you got the altitude, and you got the seeing, and I've got the infrastructure. So I've solved all the hard problems. So it's always going to end up being location. Do you want to go for smaller survey scopes? I'd recommend SOFAR would be fine. You start getting bigger scopes, you're going to start getting limitations at the actual site. So those are the type of things that you had to deal with. We had the same thing with the University of North Texas, where we had the MONROE Observatory. We can have 16-inch telescope in Gainesville in the Muggy Bottom up there on the Red River. We have limitations with light pollution and the seeing. And so going up with 20-inch and 24-inch telescopes, you really need to go a true mountain location that has good seeing, and you can look anywhere in any research you want to around the country, and you'll find that McDonald's still the darkest. It's darker than anybody else in the southwestern major observatory locations.
So you're not recommending to do anything local meaning 3 hours?
Yeah, you could do it immediate, but it's only a few years away from something else being another impact. The chances of having major industry and impact in Fort Davis, Texas, is much more removed than it is around here. You're only, 1 oil patch away from opening up Throckmorton again, to things around there. You have either things north to the south. It is great right now, but same way with the Star Ranch. I love that for visual, but I could have set it up for remote. But in the scheme of things, the amount of infrastructure that it'd take, and then how long would the payback be, I made the decision to go ahead and go to a true observatory location. And that's why I set it up there across from McDonald Observatory. So those are the considerations, things to think about. Certainly, I always tell people that you want to set something up, get your feet wet remote, and try to do that. That's a lot of work to do. Just go ahead and rent one out my facility for a few $100. You know, and you can do that for the club and start you know, seeing what it's like, and try various different instruments and become familiar with it, and see what that experience is like with your club members, and do the buy-in as, is this what we want to do? We think we want to do it, but it's a lot of effort to go buy the telescope, go set it up, go see what it's like, go see the site. You can just rent it right at a facility, whether it's, you know, Ron DeLilio has scopes there. I have other people have scopes there. They got nights that they don't use it. And I'm not saying that it's me who is selling that to you. I'm just saying they make it available for time when it's not do it. So there's other considerations where you can do a timeshare, say, hey, you know, we can get access to a 20-inch telescope without buying it. Maybe we want a wide field survey. So what I tell people who join the Dark Sky Observatory, it's truly a collaborative. You want to share, you know, and it's something that the club can think about doing as they step into it. There's multiple ways to do it. Don't have to solve it in 1 or 2 meetings, but you know, I would be glad to interject ways to step into that. I wholeheartedly think the future of remote observing is a key to any forward-thinking club.
Mm-hmm.
That doesn't take away from the outreach. You can do virtual star parties. You can still do a lot of different things. You can do the in-person, but it certainly opens up the next level of what a club can do when it has a remote facility that they can access, and without limitations of time sharing or all the other things that you run into. So you might, and other, you know, with other folks.
Right. Yeah, Preston, and thank you very much for that. And you know, I think when the club launched into looking at setting up their site, buying property, and so on, there was a strong emphasis on public outreach with the community, you know, and so that was the focus on keeping things within a couple hours of the Metroplex, trying to find the best that we could, so that folks, and then, you know, but we've talked about it internally, and things have changed now, you know, and I think you're spot on with the discussion of remote observing, and I think we need to step back, and this is something we can talk about at the next board meeting, step back and reevaluate what our priorities are with respect to, you know, club instruments, visual observing, public outreach, and operations with the public. And I personally think, you know, working with the Parks Department there with the public and letting them you know, manage the security and manage the insurance and all that type of stuff when you get the public involved is probably a safer bet for the club. But you know, with remote observing now being the way to go, you know, you're making perfect sense as getting a site that is sub-arc minute or arc second seeing, if we're going to invest that kind of money into the equipment. Yeah, and those, you can do all the above, but the future is being able to do, and say you have a world-class observatory location, and you can do research if you want to, you can do different projects, you can do the virtual star party, and you're going to attract different kind of people to the club from all those things, the eyeball, you know, the event-driven things when it's an eclipse, a lunar eclipse happening, or the science behind being able to do it from a remote observatory. Because you can't stand there and watch a CCD camera and get excited. You know, you need to see it online and participate. And you can do that in a Zoom meeting to collect the scientific data and have a learning process. So that's a different type. That's what we do with our students, and how they go into, oh, that's what we're looking at. Oh, that's why it's important to do this. And so you can do that as a club and actually return good data back to the astronomical community.
Would there be an impact on accessibility if, say, an entire club, say we had 10 or 15 people, myself included, all of a sudden wanted to sign up for time? Do we run into a scheduling crash where we can't get on?
So what you do, and the way it works, is when you have your own telescope, you have, just like you do a board, you're going to have the person that is, and the way we do it, that as the observatory manager, you have the person who's in charge, like you do at an observatory. You ask for time, you do time scheduling, and then you get to be the boss. But in other words, if the science is so important that something's happening, then you can make a decision. The reality is, rarely do you get conflicts because it's something that's really happening at the same time. Usually the people want to partner together and collaborate instead of trying to do it by themselves, because usually it's complex enough that it's not a one-person show. So I think you would find that it's not as difficult to schedule time and make things happen as you might think. And people will find that when it comes to imaging, they can do it on almost every clear night. And one thing about being out in West Texas, you get more clear nights than any place else on average. And you can look up the statistics from the 1990s. So you get a lot of clear nights. You can go all the way up to the full moon. If you want to do pretty pictures, you can still do, science even during the full moon, but visually you don't. So there's a total time shift and different things that go on. So the answer is yes, it can happen, but rarely does it happen that it becomes a conflict and not one that's hard to solve.
You can adjourn the official meeting and then people can go on and discuss them.
I already have. Anybody else have something they want to discuss? Okay. Anybody else? All right. Well, then we'll go ahead and close the meeting unless anybody wants to speak up. And thank you very much, everybody, for attending. It's been some very interesting conversation here at the end. Thank you.
Good night, all.
Thanks,
Night.
Thanks, Michelle, for hosting.
I'll be in.